Here in chapter 5, we're going to talk about the integumentary or skin system. So first of all, what are the functions? And most of these, we definitely can think of the functions and think of the parts. So again, integument, we're mainly thinking about skin, but that does also not only include the skin, but that also includes the hair, the nails, as well as glands that go along with the skin. So again, like our sweat glands, so it's not just the skin, so our integumentary system makes up those 4 parts. As far as functions, of course, protection, not only against microbes or microorganisms, but also against UV. So thinking about, of course, skin cancer, but that skin protects our underlying organs from UV radiation. It also helps against water loss. Of course, provides sensation so that we can feel things like heat and cold, touch, pressure and pain. Helps us to regulate our temperature. So we think about like shivering, but also sweating. So the sweat glands, again, glands being part of the integumentary system. Those sweat glands release water. Water conserves heat. So releasing water releases the heat. Also, one we may not think about as much as far as a role is vitamin D production. So this is actually made at the skin because it requires UV light. So again, individuals who, especially like in Alaska, where their days, they can have almost 24 hours of dark. So again, vitamin D is essential to them. So having that UV light exposure is required to make vitamin D. So that all is happening at the skin because that's where UV is going to be allowed. And then finally, excretions. So of course, we think about the kidneys with excretion and getting rid of waste, but some of it also gets sweated out. So waste products can be eliminated in our sweat as well. So just looking first of all here at the skin. So the skin, we have the outer layer, which is called the epidermis. So think about epithelial is on the cover, the outer layer. So epidermis is the superficial or outermost layer. That's where we're going to have that stratified squamous epithelial tissue. So it's constantly sloughing off. We're losing layers and layers, but reproducing those. That's going to provide that protection as well as helping to reduce water loss. Then underneath the epidermis is the dermis. This is the deep layer. Now we're talking about connective tissue. So our epithelial on the outer layer, connective underneath, and this is that strong structural support. And then we also have subcutaneous tissue. This is actually not considered part of the skin, but this would be some of the loose connective tissue of the underlying structures that we talked about some of those in chapter 4. So if we look at the epidermis is avascular, meaning there is no blood flow to it. So of course it needs nutrients for those cells. So that those nutrients come from diffusion from the capillaries from the dermis. So essentially vessels come in to the dermis, nutrients, oxygen gas exchange, but all those nutrients come into the dermis through capillaries, but then just by simple diffusion, they permeate out to the epidermis. So this is made up of those epithelials. Again, it is stratified, so they're in layers, and then it's separated from the dermis using that basement membrane. So if you remember, part of our epithelial tissues, those cells have a basement membrane where they connect to the underlying connective tissue. So the epidermal cells that we find on the skin, so we have keratinocytes, as the name implies. They produce keratin. This is the majority of the cells that are going to be found there. So they're making this keratin that is needed to provide strength, again, protection against invaders, but also preserving that water loss as well. There are also melanocytes. This is what gives us our skin color by producing melanin. It is then transferred to the keratinocytes. So the same number actually of melanocytes are in all people regardless of skin color. So it's not the number of cells, it's the amount of melanin that's actually being produced. Langerhans cells, this is actually part of our immune system, but we find these cells out in the epidermal tissue. Again, they are looking for any type of invader. So if some do penetrate, they can be defended or detected. And then Merkel cells, they detect light touch just to get a little bit of superficial pressure. So a little bit of sensation occurs with those Merkel cells in the epidermis. And then just a term here, keratinization. So as cells move out through the layers, so again, thinking about the dermis, so starting at the basement membrane of the dermis, moving out to the outer layer of the epidermis, what happens is they fill with keratin. So the cells on the outermost layer have the most keratin, so the strongest. The ones closest to the basement membrane have the least. But as they move out, that then causes them to die. But this then they get sloughed off. That's why we leave skin cells everywhere we go. But it serves as a layer, again, to resist abrasion. Again, think about the strength of that keratin, and also a permeability layer. So again, things aren't moving in and out quite as easily. Now, what's referred to as the epidermal strata. So a few different, you'll see stratum here in all of these terms. So stratum basal. So this is the deepest part of the epidermis. So it's just a single layer. A lot of mitotic activity, which is just mitosis, cells dividing to make more, because again, we're constantly losing these epithelial cells, so they're constantly being replaced. And that's the job here at the base, so that basal layer. Also, this is where cells start to become keratinized, and that increases as we move out. Then the stratum spinosum, limited cell division. Again, that's mainly in the basal. Those desmosomes, we think about those connections that get made. Now these lamellar bodies and additional keratin fibers start showing up here. Then we have the stratum granulosum. This has what's referred to as keratinohyaline. And then in superficial layers, the nucleus and other organelles actually degenerate and the cell starts to die. So again, as we're moving away from the basement membrane, those cells are less active. They're starting to fill with keratin and die. Then the lucidium is a thin clear zone. This is actually only found on the palms and the soles. So the palms of our hands, soles of our feet is the only place that we're going to find the stratum lucidum. And again, that's that thin clear layer. And then the stratum corneum. This is the most superficial, so the farthest layer out, and it has cornified cells. So again, thinking about resisting abrasion and providing that protective layer. And just kind of a visualization of all of these layers, so kind of our cartoon animated drawing, and then actually what it looks like with histology here. And again, this is closest to that basement membrane right against that dermal tissue. So that first single layer is going to be the stratum basal. That's again mitosis. Those cells are actively dividing. Then we move into the stratum spinosum. Now we're starting to fill with that keratin fiber. Again, we get these desmosomes that we can see here. Again, those are those connections that are made between these cells. We start to see them throughout. So as they fill here, we move then out to the stratum granulosum. Again, we're getting more into more keratinized, so that keratinohyaline granules, again, more and more keratin. Now the cells are starting to die. Then the stratum lucidium, again, that's that clear layer only in the palms, in the soles. And then finally the outermost layer, the stratum corneum. All right, so now talking about the difference between thick and thin skin. Name kind of gives it away. But the thick skin, again, only referring to the epidermis. So we're not talking about thick dermal tissue. We're just referring to the epidermis. But in thick skin, this is skin that has all 5 of those epithelial strata we just went over. So that's going to include the lucidium, that clear layer. So again, this is going to be on the palms of the hands, our fingertips, and then the soles of the feet. That's the only place this thick skin is going to be. And it helps to, in those areas of pressure and friction, again, we have the more layer there. It helps create our fingerprints and footprints. There are papillae of the underlying dermis that occur in parallel rows. Now the thin skin is where the majority of our skin, where we only have the 4 layers, again, no stratum lucidium, so pretty much everywhere but our hands and feet. Now this is going to be a bit more flexible than thick skin without that layer, so it's more flexible. So again, covering the rest of the body, and this is where hair is going to grow. So we're not going to get hair growth on thick skin, only on thin skin. And then just a term here, sure we've all come across these or had them. So a callus So this is just what happens is we get an increased layer of the stratum corneum, again, the outermost layer here where it's already very keratinized, again, dead cells. But whenever there's an excessive number of layers, they actually covers over a bony prominence, or a corn can actually form from that callus. So again, just an extra thickening of that stratum corneum leads to a callus. And then if it's over a bony prominence, then a corn can actually form. All right, now talking about skin color. So this is actually determined by 3 factors. So the pigments of the skin, so we talked about melanin, but also blood circulating, and then the thickness of that stratum corneum, again, the outermost layer of the skin. So if we look first at the pigment, so we already talked about the melanocytes and melanin. So this provides protection against UV light. So it's made by an amino acid called tyrosine, and it's colored brown to black. It can also be kind of yellowish or reddish. So again, we think about the different skin tones that we can see. It's based on the melanin. So again, melanocytes we already talked about. It's the process that extends between those keratinocytes, and it deposits the melanosomes. Now, the opposite, or the loss or inability to produce melanin, leads to albinism. So this is, again, deficiency or even absence of the pigment, and that's due to genetics, hormones, or even light exposure. And then another pigment is carotene. So we think about these with carrots. So it's kind of a yellow pigment from vegetables, but this actually accumulates some in the stratum corneum, also in the adipose cells of our dermis and that subcutaneous tissue. So it's not just melanin, there's a little bit of carotene in the skin as well. Now, looking at just how this happens, so the melanin transfer to those keratinocytes. So again, melanocytes, everyone has the same number of those, but they produce and package different amounts. But they package that into vesicles of melanin, and those are called melanosomes. So we think about like lysosomes or peroxisomes that package things, while melanosomes package melanin. And then those move into the cell processes of the melanocytes. Then the keratinocytes that are making the keratin, they actually eat them. So they phagocytize or engulf the top layer or the tops of those cells and acquire the melanosome. So it's kind of a unique way of transferring. So again, we think about phagocytosis with like ingesting viruses or bacteria or something like that. But in this case, the keratinocytes actually eat or engulf those melanosomes that were produced by the melanocytes, and that's what's taking in that melanin and that pigment. So the other factor here, blood circulating through the skin, again, that kind of gives us a reddish hue. So whenever we get flushed or we're blushing or really mad, or even during inflammation. A couple other kind of scenarios that can happen: cyanosis, so cyanin is kind of a blue color. So this is a blue color that's due to a decrease in blood oxygen. So if somebody's turning blue, you know, we use that terminology, like if they're choking or they can't get their breath, or if they have depleted oxygen, like their respiratory function isn't very good. So again, that increased kind of bluish color, now it's not bright blue, but kind of a bluish tint indicates a lack of oxygen. And then kind of the opposite, or the other color, erythema, so that red color due again to that increased blood flow. So again, the blushing that we get, inflammation if we have in an area, so that's erythema, increased red blood cells. So the thickness of that stratum corneum also impacts the color. So the thicker it is, it actually causes a yellow, more buildup of carotene, so it produces kind of a more yellow pigment or color. So again, pigments from other substances in the dermis and subcute can also impart kind of a bluish color on the skin. So the deeper that is found, the bluer that it produces. All right, now also here talking about skin cancer. This is actually the most common type of all cancer. So most is due to UV radiation that damages the DNA, so it causes mutations in the epidermal cells. So again, those cells are helping to protect the rest of the body, but of course they themselves though are subjected to a lot of radiation that can cause mutations. So the amount of melanin affects the likelihood of developing that. So fair-skinned people are at greater risk than darker skin. So the more melanin, it's protective, helps keep the UV radiation from penetrating too far. The more melanin there is in the epidermis. But there are 3 different types of skin cancer. So basal cell sarcoma, squamous cell sarcoma, and then melanoma. So just looking at each of those, so basal cell sarcoma is actually the most common. You may have thought that it was the last one, but it's actually the basal cell sarcoma. So these are the cells of the stratum basal. So remember, those are the ones attached to the basement membrane that are actively dividing and going through mitosis. So this is the most common. It can have a lot of different appearances. There's an example over here, just kind of looks like kind of a little blister almost. It's kind of hardened. But then it can be cured though by removal or destruction. So a lot of times people go in and these are essentially just kind of scraped off and removed in order to treat that. Now the squamous cell sarcoma, this is in the stratum spinosum. So again, not the deepest layer, moving out toward the surface. Again, varied appearance, but it can actually bleed, so we can see much darker kind of structure here. But most cases, though, same as the basal cell sarcoma, can be removed or cured by removing and destroying those cells. So again, scraping them off, getting underneath, ensuring they've gotten all of those cells, and actually, again, cures it. They're completely gone, and no other cells are remaining. So physical removal is the best treatment. Now, the one you may have thought of as being the most common is melanoma, and we hear the most about it because it's the most deadly. However, thankfully, it's not the most common. So there is kind of the ABCDE rule for looking at signs of melanoma. So A is asymmetry. So if we think about a mole or some pigmented surface like we see here. So again, it's not symmetric. We don't have like a circle or anything. Kind of along with that, border irregularities. So again, you can see this is kind of like all over the place. The color is not uniform, so you can see kind of a dark spot here, some lighter spots in this area, and then the diameter being greater than 6 millimeters, and it's evolving or changing, so it's not staying the same. You start to see changes over time.